Welcome to One Wrong Move, where one small decision set the whole chain in motion. Today's story starts with a rubber ring, the width of a pencil stiffened by a cold night, and ends somewhere nobody saw coming. The night before Challenger launched, the people who built part of the rocket told NASA to wait. Cold made those rubber seals slow, and the engineers knew what that meant. Those seals sat inside the booster joint, the place that had to hold fire inside the rocket. The warning went into a meeting. It came out as permission to launch. Nobody had changed the weather. Nobody had changed the rubber. They had only changed the decision. The next morning, Challenger lifted off. 73 seconds later, it broke apart. All 7 people on board were killed. January 28, 1986, Cape Canaveral, Florida. The Space Shuttle Challenger was sitting on the pad, waiting to fly. This launch was different. The whole country was watching it. Because one of the 7 people on board was not a professional astronaut. She was a school teacher named Krista McAuliffe. She was going to teach a lesson from space. Kids across America were watching live in their classrooms to see their teacher fly. She had been picked out of thousands of teachers who applied. She was the face of the whole program. So this was the launch everyone wanted to go right, and it was running late. To understand what went wrong, you have to look at the rockets on the side. The shuttle had 2 tall white boosters strapped to it. They did most of the lifting at the start. Each booster was not one solid tube. It was built in sections, stacked on top of each other. And where 2 sections met, there was a joint, a seam. Inside that seam, burning fuel pushed out with enormous pressure. Something had to hold it in. That something was a rubber ring. They called it an O-ring. Think of a rubber band stretched around the seam, sealing it shut, 2 of them, one behind the other. One was the main seal. The second sat right behind it, as the backup, in case the first one leaked. Their whole job was to keep the fire inside the rocket from escaping through the seam. Remember the rubber ring. The entire story turns on it. Here is the part that matters about rubber. Rubber has to be springy to seal. At ignition, the seam flexes open for a fraction of a second. The ring has to spring out and fill the gap that instant. When rubber is warm, it springs back fast. It chases the gap and seals it. When rubber is cold, it goes stiff. It springs back slowly. And slow is the one thing it cannot be. If the ring is too slow, the gap opens before the seal closes, and the fire finds a way out. Behind that seam is burning rocket fuel, hot enough to cut through steel. It is looking for any gap it can find. The engineers knew this. They had seen the warning signs already. This was not the first time the seal had been a problem. On earlier flights, they had pulled the boosters out of the ocean and looked at the joints. And more than once they found the rings were scorched, burned, eaten away in places. Hot gas had gotten past the first ring. On some flights it had started past the second one too. That is the only thing standing between the fire and the outside, the second ring. So the seal had been failing a little for a while. But every time, the shuttle came home anyway. Nobody got hurt. And here is where the human part goes wrong. Slowly, the damage started to feel normal. Each flight that came back, scorched but safe, became proof that the danger was acceptable. A flaw they had never fixed quietly turned into a flaw they had learned to live with. Sociologists later gave this a name, the normalization of deviance. You get away with something dangerous once, then again, and slowly the danger stops looking like danger. There was even a colder launch the year before, with the worst burn damage they had ever seen. The warning was right there in the data. They flew again anyway. So by early 1986, the seal was a known weak spot, a problem with a long paper trail. One engineer had even put it in writing months earlier. Fix this joint, or we could lose a flight. If you can already feel where this is going, stay with me, because the worst part is a decision, not an accident. And if this is your kind of story, hit subscribe right now. Now go to the night before the launch. A hard freeze was coming to Florida, a real one. By morning, the air at the launch pad would be around 36 degrees Fahrenheit. That would make it the coldest shuttle launch anyone had ever attempted. But the air was not the worst of it. The seam on the booster was colder still. Sitting in the shade, chilled by wind and a tank full of super-cold fuel, that joint was estimated at around 28 degrees. 28 degrees, below freezing, on the one part that had to stay springy. And here is the number that should have ended it. The boosters had never been tested below 40 degrees, not once. The coldest launch before this one had a seal temperature around 53 degrees. Now they were talking about flying at 28, far below anything they had ever proven safe. That evening they got on a phone call. 3 rooms, in 3 different states, all on the line. NASA was on the call, and so was the company that built the boosters. The engineers at that company laid out the case. Cold makes the rubber slow. Slow breaks the seal. Their recommendation was clear. Do not launch. Wait for it to warm up. These were the people who built the thing. They were saying stop. And NASA pushed back, hard. This flight was already behind schedule. There was pressure to fly, and everyone felt it. NASA wanted to know where the hard proof was that 28 degrees would fail. And that was the trap. The engineers had a strong warning, but not a clean, simple number. Their data was messy. The cold flights and the warm flights did not line up neatly. So they could not prove it would fail. They could only say it was a bad risk. And somehow on that call, the question quietly flipped. It stopped being prove it's safe to fly. It became prove it isn't. Then the company asked for a few minutes off the line on their own. The managers and the engineers went quiet, away from NASA to talk among themselves. And inside that room, the engineers still said the same thing. Do not fly it this cold. But the managers were now under real pressure to give NASA a yes. And one senior manager turned to another and said a line people still repeat today. Take off your engineering hat, he said, and put on your management hat. Stop thinking like the people who know the rubber. Start thinking like the people who answer to the schedule. The managers took their own vote. The engineers were not part of it. They voted to launch, and they got back on the line and told NASA, yes, go. NASA asked them to sign the recommendation to put the go in writing. And the company's top man at the launch site would not do it. His name was Alan McDonald. He was the one who had to sign off for the booster company. And he flatly refused to sign it. He thought they were taking a risk they had no business taking, so he would not put his name on it. A manager underneath him signed it instead. The paper went through. Stop here. Look at what just happened. The people who built the rocket said do not fly it. The people who knew the rubber best, who had seen the burns, said stop. And they were overruled, not by better data, by a vote. A handful of managers in a side room decided the warning was not proof enough. The one man who refused to sign was right, and his signature did not matter. That is the one wrong move, not a broken part, not bad luck. The people who knew the most said stop, and a vote said go. Everything after this is just the cold doing exactly what they said it would. Morning came. The freeze had been brutal overnight. Ice had formed all over the launch pad and the service tower, long sheets of it. They waited a couple of hours for some of it to melt, then pressed ahead. At 11:38 in the morning, Challenger lifted off. And in the very first half-second, the cameras caught something nobody wanted to see. A puff of dark smoke coming out of that joint on the right booster. The seal had already failed. At the instant of ignition, the cold ring had not closed in time. The exact thing the engineers had warned about, on the exact joint they had pointed at. For a few seconds, they got lucky in a cruel way. Burned material clogged the gap and plugged the leak. By chance, it held. For about a minute, the shuttle climbed, and it looked like a normal flight. Then it hit the roughest, windiest part of the climb, the hardest shaking. And the plug that had been holding the leak shut got shaken loose. The flame came back. This time it came out as a steady jet of fire. A blowtorch on the side of the rocket pointed at the giant fuel tank in the middle. The fire burned through a strut, then into the tank itself. At about 73 seconds, the tank let go, and the whole stack came apart in the sky. Not a bomb going off. The shuttle was torn apart by the wind and the forces in an instant. All 7 on board were killed, including the teacher the whole country had been watching. Down on the ground, the voice on the loop said the only words that fit, obviously a major malfunction. 73 seconds. That is how long the launch they were warned about lasted. The country wanted to know how this could happen, so they built a commission to find out. On it was a famous physicist with no patience for spin. His name was Richard Feynman. He had heard the officials insist the cold rubber was fine, so he did something simple. On live television, he took a piece of the same O-ring rubber and a glass of ice water. He squeezed the rubber, dropped it in the cold water, and held it there. Then he pulled it out and showed everyone. The cold rubber did not spring back. In a few seconds, with a glass of water, he showed the whole country what killed the crew. Cold rubber goes stiff. Stiff rubber does not seal. That was the entire disaster in one cup. Feynman also dug into how NASA thought about risk, and he found a stunning gap. Management claimed the odds of losing a shuttle were about 1 in 100,000. 1 in 100,000. You could fly every day for centuries on those odds. The working engineers put it closer to 1 in 100. 1 in 100 against 1 in 100,000. The same machine, wildly different worlds. The people closest to the metal knew it was dangerous. The people up top had talked themselves out of it. If this is landing, take 1 second and subscribe. 7 people lost to a warning that got outvoted. That should not fade from your memory. The commission was careful about what it blamed. Yes, the physical cause was the cold seal in that joint. That part is simple. But the deeper cause was the decision, the way the warning never carried the weight it should have. A flaw they had learned to live with, a schedule pushing hard, messy data, and a room where the question got flipped and the engineers got outvoted by their own bosses. Feynman summed it up in one line that has outlived everyone in that room. For a successful technology, he wrote, reality must take precedence over public relations, for nature cannot be fooled. You can vote however you want. The rubber does not care how the vote went. The shuttle program stopped for almost 3 years. They redesigned the joint with a better seal and added heaters to keep it warm. The exact problem the engineers had begged them to wait on got fixed after. As for the man who would not sign, he told the truth to the commission. And later he said refusing to sign was the smartest decision he ever made. He spent the rest of his life teaching young engineers one thing: when you know, you say so, and you do not sign. Step back from the whole chain. It started with a rubber ring that goes stiff in the cold. A flaw they had seen, and scorched parts they had pulled from the sea and chosen to live with. A freezing night, and a joint at 28 degrees, far below anything they had ever tested. A phone call where the people who knew the most said stop, and a side room where their own managers took a vote and overruled them. One man refused to sign. They found someone else to sign instead. 73 seconds, 7 lives, a teacher who never got to teach her lesson. That is the one wrong move. The warning was there. The refusal was there, and a vote went the other way. The people who knew the most said stop, and nature did not care how the vote went. A warning that was right, a signature that was refused, a vote that went the other way. If this one got you, hit subscribe. One wrong move drops a new one twice a week, and the next one is worse.